We have a catastrophic misunderstanding of scale. We see our nearest star on a map and think of it as a neighbor. But in the language of physics, Proxima Centauri is an impossibility. It sits 40 trillion kilometers away. A distance so vast that if you left Earth today in the fastest machine ever built, you wouldn't just be late, you'd be extinct. Voyager 1 is currently screaming through the dark at 61,000 kilometers per hour. That's unimaginable speed. To the universe, it's a standstill. If Voyager were aimed at Proxima, the trip would take 73,000 years. That is 3,000 generations of humans born. By the time you arrived, the civilization that sent you wouldn't just be gone, they'd be forgotten. The stars themselves would have shifted their positions in the sky. The problem isn't just the engine, it's the medium. Space looks empty, but at 20% the speed of light, the vacuum becomes a solid barrier. At those speeds, a single atom of hydrogen strikes your hull with the energy of a localized explosion. A grain of dust becomes a kinetic missile to accelerate even a small payload to a fraction of light speed. You'd need to harness the power of a medium-sized star. We aren't just lacking the technology. We are fighting the fundamental energy scales of the universe. Right now, there is no known way to survive the trip. And even if we solve the physics tomorrow, we'd hit the weight equation. It is a brutal logic of interstellar travel. If you launch a ship now, a faster ship, built a century later, will overtake you. You would spend your entire life in the dark, only to arrive and find that the people who stayed behind beat you there decades ago. This is compounded by time dilation. Physics dictates that the faster you go, the slower you age. You might arrive at Proxima in what feels like 5 years, but on Earth, a century has passed. So, why is the closest star too far? Because the universe has a speed limit, and we are nowhere near it. We can see Proxima Centauri with a telescope. We can dream of its planets. But until we find a way to rewrite our understanding of energy and time, the closest star is exactly where it's going to stay.